everybody. My name is Obi-Wan Pez, and this is Simplex Pachinko. We are looking to do some math by request tonight. So if anybody has any particular things that they would like to talk about, let me know. Ooh, syntax. Nice to see you again. Laz, good luck on your 3-hour-long exam that's due in 2 hours. Thinking of thickness. Okay. It's a lovely, vague start to the question. Like it. Let's see. Go over the way you define it, and then what kind of problem I've been having? Sure, go for it. So, the thing that I have learned how to do, Laz, is go into my calendar thing and be like, alright, I need to get it started by, like, this point. Ideally, if they're giving you, like, 2 days to get it done, you want to set a calendar reminder, like, before you go to bed to at least read it. And then, pretty much no matter how long the exam actually is for, or quiz, whatever, I would recommend reading it the day it's assigned, because your brain starts working on stuff even if you're not actually consciously aware of it. And then, yeah, like somewhere around the halfway mark, I'll put another calendar reminder for something, and then, you know, a few days before it's due, another one. Whatever time period is necessary for it, because, like, that's one of the things, is that I will forget stuff. It's been much worse since COVID. So, yeah. I just obsessively set calendar reminders, and it seems to work out okay. Canvas to both personal and student, yep. Hooray! Alright, if we have a function which is continuous and differentiable, we want curve, such that from all points on F, we take its normal and travel L in or opposite that direction. Okay. So let's start drawing a diagram just to make sure I've got the right idea. So, some curve, doesn't really matter what it is, continuous differentiable. And then we say we've got a particular point. From all points, right? Right, take normal. And travel a given direction, or a given distance, L. We'll make that work for us here. Assume those are all the same. Okay, or in the opposite direction. Any rhyme or reason as to which? So if it's not a choice, right, you want to draw a vector in the direction of the normal of length L in both the positive and negative direction, I suppose. Could be the way to say it. It's way too hot to drink still. Right, in certain areas these are definitely going to overlap each other because we're doing all points. So if we get 2 points which are on an exceptionally curvy curve, then we end up with 2 normals which are going to overlap each other. Yep. And most of the rest of these are not exactly going to be sort of close. Okay. Area can be computed with int AB square root of 1 plus f prime squared dx. So that would be surface area, or arc length. Yep. Multiplied by your L. Okay. Yep. So it's always going to be height L. And yeah, when it doesn't overlap. So I think you're also going to have a little bit of potential trouble in... Well, no, not really, because, again, continuous. So we're doing all points. Yeah, okay. No, I'm good. So if they were to overlap in a really significant way, like this, then I assume that you would want this to either be subtracted off, right, or just not counted at all. I think that that is going to be very tricky. Now that is a naive perspective because I have not actually looked at this. From a computer perspective, it'd be real easy. So you'd say, like, I want you to calculate the integral, provided that it doesn't end up, find the area out to L or an intersection of these two lines, or minimal intersection. You end up with something like this. We only want it to calculate, like, out to here, say. Right, wherever these points end up being. The intersection points that are closest to here. And when we're doing, this over an infinite number of points, it kind of falls out. It makes it obvious where you're doing this. Okay, yeah. So largest L where there are no overlaps. So that also is going to be, that is going to be a part for Zach to look at, because that's some real analysis stuff. If you should, in fact, be able to find a largest L by... I mean, we ended up calling it mean value, or not mean value, yeah. You can use... So I think if you can show that there is some largest L for, in fact, all functions, it doesn't matter, like, what function you have, there is always going to be some largest L when it has any sort of curve. If you have a completely flat line, you could go to infinity. But in that case, it's boring, so why would you do it? But I would recommend saying that there is, as long as it is a curve, there is going to be some largest L value for which this will work, and if you can find that largest L, then this is how we're going to proceed. And you could always just do the integral times L, whatever that is. At least I think so. And it's been a long time since I've really done any sort of work in real analysis or numerical stuff. Number theory. There we go. Oh. Oh, what went wrong? Holonami, how's it going? Simplices combinatorial, categorical, or topological. They are more combinatorial, I would say, probably, or at least the ones that I am that I did my half-ass research on and named my channel after. My problem is that I need to formalize a method by which Python or some other language will create an n-dimensional matrix, and I'm not particularly good, let's say, at like almost any programming language at this point. I think my strongest is probably MATLAB, and even that's, you know, simple stuff. At this point, I've fallen so far behind. Let's see. Yeah, I had for a while been working on trying to do some stuff with Lean Prover and Project Euler. I know Dawn Does Math really likes working on some of the Project Euler stuff. I haven't done it in a while, but let's give a shout out to Dawn there. Anybody who doesn't know Dawn Does Math, and is currently live. In Project Euler, you... right. Should probably sign in, I guess. Yeah, I have not gotten super far, at least in Python. For MATLAB, I think I went... I think I was on Project 40 or something like that, but... No, so my n-dimensional matrix is to try and just, like, input... I mean... So I need it to be of variable dimension, which means that at any moment I could just ask it to plug in, you know, fourth or fifth dimensional or whatever else I want to do. Or just, you know, 2, because 2's fairly easy to work with. And that's the standard. So I had been doing the Pascal's triangle computations. So n choose r. And so I would like to pull all possible coefficients from the nth dimension kth row of whatever slice we're working with. So my actual channel name comes off of this picture, sort of, where my dean was trying to do some work researching with students at our community college on how to create a three-dimensional simplex, and then figure out the same patterns that exist in Pascal's triangle here over on the 3 simplex. You know, 2 simplex moving up to 3. So I was working in one direction where I was taking all of the horizontal cuts, which is what you see where it says n equals 3, and then moving to the right where it has 1, 3, 3, 1 around the outsides, and then 6 in the middle, 1, 4, 6, 4, 1 around the outsides, and 12s in the middle, etc., etc., etc. So all of that stuff moving through. I was trying to figure out, you know, slice by slice, what all of those values were going to be. And I generalized it. It was super easy because it's just n choose k1, k2, k3, k4, etc. However far you need it to go. Number of dimensions are the number of choices that you're given at each level. So, you know, when you're talking binomial theorem, n equals 2, you can either go left, right, left, that's your right, left or right, and it reaches a certain state toward the end. When you go up to n equals 3, now you have 3 choices. So you could go toward A or B or C. And so I did that on that picture. That particular picture, I did a really crappy version myself. It's actually, I think, on my profile. So I did a really crappy version of it, and a graphic designer friend of mine ended up making this. And I was like, dude, how much do I owe you? And he's like, please. I was like, no, really, I need to pay you for your work. He's like, come on. How long have we known each other? I'm like, ugh. He was like, if you want a real, actual good one, this is something I knocked together in like 30 minutes. If you want an actual piece of art, then I will point you in the right direction. I'm like, okay, fine. So yeah, I was hopeful that we do some... I mean... I'm hopeful that someday I can actually work on Project Euler in earnest, but for the moment I'm getting stuck on pretty easy stuff, so it's you know, I need to improve my coding even before I do some of this stuff. ND array from NumPy, okay. That might help. I also am running Ubuntu, so there's several things that they're like, why don't you use a different distro? And I'm like, but that involves like either partitioning or wiping out a whole bunch of stuff, and I don't want to do that. I'm starting to turn into grumpy old man, and it's, my kids would probably at this point say starting. Arch, yeah. But I pulled up NumPy, and it wasn't as easy as just like pulling something online. I probably could do it now because I'm at least somewhat well versed in using Ubuntu, and like might be edging ever so slightly closer to becoming a power user. We'll see if that happens before the fall off starts happening in my brain. But yeah, the I've been trying to get yeah, I think it's pip that it does actually work with, and then I have to redirect it in a bunch of different ways to make sure it gets to the right place. But yeah, maybe that's just my misunderstanding. The other thing that I was trying to do, I was trying to get DaVinci Resolve to work, and like I just can't get it to work, and like I'm trying to follow some guy's video on YouTube, and I'm just like, I just need this to work. It's so close to working, but I was asking a guy about this thing, and he was like, well, you should be able to fix it doing these series of steps, and I followed those series of steps, and it did not do it. So I still need to go back a couple more times and, you know, have a quick chat. But it also makes me ever so slightly sad, because if I had DaVinci Resolve working, a lot of my stuff would be on YouTube by now. So, like, I need to get on it. But, yeah, and that's the other thing, is my kids are also home for the rest of the week. So... yeah, that could be nice. Thank you. Oh, and we also did Lean. If anybody does not know Lean Prover, Lean itself has its own community, and you can do math, and there's all sorts of cool things that you can do with it. You can have your Ubuntu installation of Lean itself, or you could get used to Lean in the natural number game. This is something else that we've been doing for a while. I haven't actually finished it. We're getting kind of close, but... This is adam.math.hhu.de, so it is a Deutsche website. However, that should work. Yeah. If anybody is interested in learning Lean or trying to, okay. Learning Lean or trying to understand how Lean works, this is a very decent website for it. from the home here, we have our tutorial world, numbers 1 through 8, addition world 1 through 5, multiplication, and implication. From here, this goes to algorithm, advanced addition, and power world, and then to inequalities, and then to advanced math, advanced multiplication. So the structure of this is very much in the same vein as a linear algebra class, where you go all the way back to the beginning, and it's like, okay, here in tutorial world, we're going to learn some basics. So in this case, right, it's going to tell you about reflexive property. And using the reflexive tactic in Lean is going to say that the thing on the left-hand side is going to be equal to the thing on the right-hand side. If it is not literally equal, it will fail. So, you know, be careful. And when we do this, we do substitutions. So in terms of here, we have h is the statement y equals x plus 7. And down here we have 2 times y is equal to 2 times x plus 7. We want to replace y with x plus 7, which is statement h. So we say rewrite h. And when we do that, it then automatically plugs in, as we see at the bottom here, 2 times quantity x plus 7 is equal to 2 times quantity x plus 7. And then we say, hey, that's a reflexive property. You could, in fact, do all this on one line and say, like, I'm just going to do rewrite h, comma, reflexive. And then it'll execute those in order. If you're confident with what you're doing, it just pops in. And then we start talking about, like, what does successive mean? So there's some other really neat pathways to get through all of this stuff. Addition world, we start looking at induction. So using the induction tactic, how do we then go through any particular proof and say, like, you know, this symbolic logic proof is going to get us step by step through this whole process. We're going to say run an induction n with d and hd. So then it says our goal 0 plus n is equal to n is our ultimate goal. Induction n says that we're going to run an induction on the variable n. So what do we do with induction? Well, induction proofs say we're going to start with a base case, and then we're going to assume that it's going to work for any particular, in this case, d. Nope. It's going to work for any particular hd. So in this case, 0 plus d is equal to d. And then we have to prove that the successive is also going to work for that. So when we go through this, we said, okay, this is the goal, 0 plus 0 equals 0. We just said rewrite the add 0 function, which says 0 plus 0 is just 0. So 0 plus 0 is reflexive. That's our base case. And then when we move here, we assume that we can use 0 plus d is equal to d, and then we have to show that 0 plus the successive of d is equal to the successive of d. So there's all sorts of cool stuff. Like I said, it gives you examples, it gives you the ways in which you can actually plug this stuff in. And we ended up making it through multiplication and implication. I have not seen Power, Advanced Addition, or Algorithm World at all this playthrough, so we'll see how it goes. But yeah, natural number game is very much here's the beginning of a linear here's the beginning of an abstract algebra class. Go. Yep, and there is a great community that works on actual, or like expanding actual mathematics out further. And the ultimate goal for some of the research groups is to give the language and some basic rules to an AI system and have it learn mathematics from scratch. And then, once it gets the basic rules down and has a structural framework on which it can work, then they're going to start saying, like, go prove some stuff, and then get back to us when you found some interesting statements. So the AI ultimately is, going to be designed in order to create new mathematics that does, in fact, play by the rules. It won't give you some weird hallucination like the large language models. If anybody does have any questions on mathematics, I am very willing to answer anything there. I can also just start on some math puzzles or various other things that I have laying around. Or we can pop on a Discord and find some math problems to work on. But whatever anybody feels like, we shall be here. And yesterday's... Okay. For anybody who doesn't know, my name is Obi-Wan Pez, and this is N-Simplex Pachinko, and I also work on a differential equations class, which I am currently teaching on Monday, Wednesday nights at the same time as this stream is, any other time. So that's 9 p.m. BST, 2,000 hours, I guess, whatever it's called. UTC, which ends up being 1600 Eastern US and 1300 Western US, so Pacific. I am an American. I am currently living in Great Britain, in the UK, in Yorkshire County, so if anybody is curious about what that's like, I can also speak to some of it at least. Let's pop into Power World to see how things go. Alright, this world introduces exponentiation. If you want to define 37 to the n, then, as always, you will need to know what 37 to the 0 is, and then get successives, etc. You can probably guess the names of the theorems. Pow 0, pow success, successive, and successive b is equal to a to the b times a. Using only these, can you get past the final boss level? Sean Carey, Europe student at Imperial College London. Awesome. Alright, so proof that 0 to the 0 is equal to 1. Now, this is a big asterisk. We've talked about this before when I did this. This is actually an indeterminate form, but Lean is going to decide to prove it this way, or to show it this way. Alright, not every 0 to the 0 is going to be equal to 1. Some 0 to the 0s are going to be 0. And some are, I believe, going to be infinite. Maybe not. No, because if it's going to 0, it's not. Okay, never mind. Some can be 0, some can be 1. Okay. So here we need to run an induction. That was not correct. What do you mean? Oh, just using POW 0. reflexive is not allowed in RFL. There we go. I was going to say, I know reflexive property works. The problem with this is that REFL was the reflexive property in an earlier version of this game, and it's just stuck in my head. Okay. So we can use power successive. Okay, and then, I mean, we can just multiply by 0. Rewrite mol 0. Yep. For POW 1, all naturals, a to the first is equal to a. Prove it. Alright, 1 is a successor to 0, so rewrite as power successor. Nope. Hang on. 1 is successor 0. No, that's not right. Numbers. Equals. Okay, and then we go back to the exponentiation. This is going to be rewrite power successive. Rewrite power 0. And yeah, let's rewrite 1 mol reflexive. One to the m is going to be equal to 1. So repeat, rewrite 1 equals successor 0. Repeat, rewrite rewrite power successive? No. Might need induction to do it. On M. Okay. Power 1 we don't have. 0 raised to... No. Okay. So we'll go back. Here. Retry. Induction M on DHD. Nope. Man. In. Hang on. Multiplication. Induction with. Oy. Hey. All right, rewrite power of 0. Reflexive. Okay, so 1 is raised to a successor, so here we can say that we want to rewrite how suck. And rewrite HD. Rewrite nope. 1 mole. And reflexive. Cool. Alright, so working through this, we said get induction on M, our variable at the top here, with DHD sets up the parameters. D is our variable, HD is the statement that we need when we're doing induction. So our induction statement is that we're going to be taking for granted that 1 to the D is equal to 1, and then we need to prove that 1 to the next number up is also equal to 1. So we did that down here. We said we're going to rewrite our successor up top, 1 to the successor of D is equal to 1, as 1 raised to the D times 1, or 1 raised to the 1 in this case. Then we split those cases and we say, all right, well, we could rewrite our initial assumption, which was that 1 to the D is equal to 1, which gets us 1 equal to 1, and then we rewrite as 1 is being multiplied times something, so we get that thing that we started with, which is also 1. 1 equals 1, use reflexive. Okay, power 2. So for all natural numbers, a squared is equal to a times a. 2 is a successor, so rewrite 2 equals successor 1. And now rewrite power successor. Rewrite pow 1, and then reflexive. A times A equals A times A. Pow add. For all natural numbers, we have A, M, and N, where we have A to the M plus N is equal to A to the M times A to the N. Like, I think we should just do induction. So we're going to rewrite 0 add and 0 pow 0. Cool. So a to the n is equal to 1 times a to the n. So rewrite 1 multiplied. Reflexive. Alright, so now we have the intermediate goal where m is 0, and then we need to assume that m is just some d value that's further out there, and our natural numbers. Right, so here, repeat, rewrite, oops, successor. Successor. No, not repeat, because these are not doing the same thing. Successor add, and also power successor. Uh-oh. Oh. Interesting. Okay, so in fact, we're going to go up here. We can do repeat. And this is just going to be... No, I don't think I can, right? Yeah, the one on the left doesn't work. No, not gonna undo what I did. So this is going to be successor add and power successor. We're just going to repeat both of those until it's happy to... It still didn't break up successor of D, which is weird. So rewrite pow successor yet again. Okay. Okay. Rewrite HD. Woo. Which then we need to rewrite a multiplicative commutativity molcom a to the n equality, or if or only if proof expected. Did not find instance of the pattern in the expression a to the n times b. Oh, that's right, because this does associativity as well. The first two things... Okay, so we need multiplicative associativity of the first two. Rewrite multiplicative commutativity of a to the n, and then we're gonna left undo, rewrite slash r, nope, l backslash l space, rewrite backwards. I don't know exactly if this is the right place to put it, but you know what? Close enough. Multiplicative associativity. Nope. Okay, where are we? Which one's going to be the left? There. Inside. Okay, so rewrite /L multiplicative associativity, and there we go, reflexive. For naturals a, b, n, we have multiplicative power. A times b parentheses all raised to the n is going to be equal to a to the n times b to the n. So again, this should just be another proof by induction. Induction n with DHD. Okay, repeat, rewrite POW 0. And rewrite multiply 1. Reflexive. Alright, so then the more complicated, what do we have when we do successors? Well, we can break out all of the individual successors. So this is going to be a repeat, rewrite, yet again, of power successor. And then we're going to break apart, rewrite HD, a to the d times b to the d times parentheses a times b is going to be equal to a to the d times a times b parentheses b to the d times b. Okay. Rewrite multiplicative associativity. If we just rewrite multiplicative associativity, right, that takes all that stuff into the center. Ugh. Alright, rewrite multiplicative associativity, b to the d. No? Is that a left multiplicative associativity? Yep. So that is going to group b to the d and a first, at which point we say we're going to rewrite multiplicative commutativity of b to the d. And then we're going to do another, this is just regular, multiplicative associativity of a. And then rewrite left multiplicative associativity of a to the d. Reflexive. Woo! Alright, raising a power to another power. Alright, induction on n. So we're going to rewrite with power 0 and also multiply by 0. This is also going to be a rewrite of POW 0. Reflexive. Okay, now the harder. What do we do with successives? Well, in this case, we're going to do rewrite as POW successor and also as multiply successor. Rewrite HD. And we have something that allows us to do that. We have multiply power. No. No. We have power add. Yep. Rewrite. Power add. Reflexive. Woo! One of the best named levels in the game, the savage Pow Pow sub-boss, appears and the music reaches a frenzy. What else could there be to prove about powers after this? The music dies down. Is that it? Of course it isn't. You can clearly see there are 2 worlds left. A passing mathematician says that mathematicians don't have a name for the structure you just constructed. You feel rather cheated. Suddenly the music starts up again. This is really the final boss. Add square. For all numbers a and b, we have a plus b all squared is equal to a squared plus b squared plus 2ab. Alrighty. With multiplication, I don't think we have any particular nice... Okay, add mul. Yeah, so here, let's do... rewrite the first instance of the square is going to be 2 equals successor of 1. I mean, like, I don't want it everywhere, but okay. That's fine. It'll be alright. Rewrite. Power suck. Oh, now you're not going to repeat it? Jeez. You know what? Let's... As much as I hate it. No, that's fine. Rewrite. Repeat rewrite. Was it POW 1? Yeah, POW 1. Okay, so now we're going to rewrite mul pow. That was not what I wanted. Add mul. This is just distribution, so we distribute the stuff that we had from a plus b times a plus b. The a plus b in the first instance is being split out to the other parts. And then we also have a left one, but... Oh, it's mul add? Yep. Repeat. Rewrite. Mul add. Ooh. Rewrite. We need the first one is gonna be multiplicative commutativity of b times a. No. Multiplicative commutativity of b Alright, now it's all in order of a times b, so that's good. We need a rewrite left of nope, additive. Nope. Yeah, additive associativity. Okay. Additive associativity of a times b. Does that change it at all? No. But it's there. A times b, a times b, b times b. What do you mean it's not there? Did not find instance of the It's because our first two things are associated again. Okay, so rewrite additive associativity. There we go. Now we do this one. Those two are grouped. A times B plus A times B. All right. Okay, so this might be weird, but we have rewrite I don't want to do repeat, do I? Let's try it. Repeat rewrite of 1 mul backwards, because we want to actually have a 1 show up in front of all terms that are A times B. Oh well. it did it by itself anyway. Okay, cool. Then we want to undo the add mul add. Undo the mul add. Is there only one? Damn it. Not quite. So should we do add mul instead? That seems weird. There we go. 1 plus 1. Rewrite. Successor equals. Add 1. Yep. Back left. Suck equals add 1. Okay. Got it on the run. Alright, so then we can say, let's rewrite the additive commutativity of the term that has suck 1 times A times B, like that. That flips those around. A times A plus B times B plus successive 1 times parentheses A times B. Excellent. Repeat, rewrite, additive, associativity. Just go. Let's go. It's all over. You proved a theorem which has tripped up school kids for generations. After all, some of them think a plus b parentheses squared is equal to a squared plus b squared. This is so-called the freshman's dream. How many rewrites did you use? I can do it in 12. Wait, this boss is stirring and mutating into a second, more powerful form. Oh, man. Ah. Fermat's last theorem. Yeah, okay, that's fair. Fermat's last theorem states that if a x, y, and z are all greater than 0, and m is greater than or equal to 3, then x to the m plus y to the m is equal to z to the m. If you didn't do inequality world yet, then we can't talk about m greater than or equal to 3, so we resort to using the hack of n plus 3 is just m, which guarantees that it's big enough. Similarly, instead of x greater than 0, we just use a plus 1. Not equal to. Right, so in this particular case, we can say that we want to do an induction on n. Repeat, rewrite, 0 add. So in this particular case, we can then say that we've got repeat, rewrite 3 is successor of 2. Yeah. Okay, and then repeat, rewrite, how suck. Anshul, how's it going? Good evening or welcome. My name is Obi-Wan Pez, and this is in Simplex Pachinko. Here we do all sorts of mathy type stuff on Mondays, Tuesdays, and Wednesdays, and then on Fridays we have a game night. I also need to get my Baldur's Gate 3 fixed. That was another thing on my to-do list. I am currently working on Fermat's last theorem, at least doing a simplified version of a proof of this in the programming language for mathematics and mathematics proofs called Lean. If you're at all interested, we can stick around here and work on this a bit, or we can go back to the whiteboard and talk all sorts of other mathy type stuff. It's late night for you. That's understandable. Yep, hope you have a great day too. I am also on Penn Center's Discord. Let me give you the link to that real quick here. So that Discord there is run by Penn Center, who is the other streamer in that list. Yeah. In that list, Penn Center is also one of the people who is on there. And you can drop into Penn Center's Discord at any point. I'll maybe eventually have my own someday, but yeah. Anyway, hope you have a good night, and we'll see you a bit later. Okay, for this, I think we're going to do a repeat, rewrite again of power 2. Yep. Oh boy. Repeat, rewrite of add mole. Oh yeah, this is gonna be really gross. Waffle Wars, how's it going? Good evening, welcome back. Alright. We need a repeat rewrite of mul add as well. Nope, that's not what I wanted. What else do I have available to me? Injective 0 is not a successive. That's fair. Well, it's certainly interesting. Repeat rewrite of mul 1 and 1 mul. Should clean it up a little bit. Nope. Okay, let's do it again. Because apparently it didn't take or something, I don't know. It doesn't want to do it. Okay, cool. So this times 1 here should be cleaned up and just say we're dropping it out. But that's weird. I don't think this should change it, but let's flip it around. Since nothing changed. No, nothing changed. Well, that's a bit strange. Anyway, we're working on lean tonight. Just doing a bit of work on the prover system that's here, and trying to figure out if we can, in this exact moment, trying to figure out if we can prove Fermat's last theorem, stating that all these numbers are... Yeah, there's a lot of numbers there. We may have to go back a ways and be like, nope, not doing it. But right, and this is also the base case. So maybe we don't do this one precisely. Like, I don't know what else we would do here exactly. So we said let's do induction on n being the powers. We know that the powers have to be greater than or equal to 3, as is the requirement for Fermat's last theorem. Excuse me. And again, we use x is greater than 0, but we say, okay, well, we just use a plus 1 being some integer, natural number. Mathematics in lean. Is that one that's already here? Yes, I already have that. Cool. Okay, so we're not going to use this. Well, how are things going with you? Let's go back. Let's say like rewrite, repeat, rewrite of left how to. Okay, shortens it up ever so slightly. Not really, but got an A on your first pre-calc test. Very nice. It was really super hard, and only the first test. I mean, if you have any questions, let me know, because that's kind of where I was teaching for 15 years. So, I mean, not location-wise, but the same class. Became the coordinator for pre-calculus for basically all of those 15. Told the university system in Maryland they were going to have to accept our transfer credits. They were like, come on, man. Like, no. We've got all these other people here from all the community colleges. We're telling you right now, you're going to have to accept our credits. Yeah, I mean, sometimes it gets that way. I don't really like that, so let's back up here. But like... Why is this not working? This right here, that right there, should translate. Because when you have all this stuff with addition between it, times another thing, right? That should recognize it as, oh, that's distribution. I need to distribute this thing. And it's just not doing it. Ugh. Alright. Add them all. A times A. That one worked fine. I don't know why that... No. Alright, so A times A. Add all. B times B. Add all. A. Add mol B. Add mol C. There we go, that's slightly better. Repeat, rewrite. How to going backwards / L. I still think this is going to fail. Repeat rewrite of multiply by 1. Oh, it worked this time. You jerks. 1 and 1 mol. That one's gone. See, this one's still here. That's a pain. This one's still here. It's multiplying by a 1. You know you shouldn't need that. What I really need is a simplify command. Symmetric. Yeah, okay, that's not it. Exact. No. Deduction apply, intro. Oh yeah, there you go. Simplify will rewrite every lemma tagged with simp and every lemma fed to it by the user as much as it can. Furthermore, it will attempt to order variables into an internal order if fed lemmas such as add com, so it does not go into an infinite loop. Yeah, infinite loops being a problem. It's just a lack of dedication, really. Okay. Rewrite. Add mul. Okay. Repeat, rewrite. Here we want to say that we've got added exponents, which need to be added. So they are currently add, no, that's square. Power add? Yeah. Backwards power add. Really? Come on, man. Got all these cases, which work just fine. Nothing. Let's get rid of the repeat and see what happens. No, okay. Power successive. Okay, no, that's fair. Alright, I hate it, but it's fair. Just that one, huh? Alright, cool. Now we'll repeat it. Right, there's not a whole lot of places where it actually exists, which, whatever, that's fine. Commences, where you been? Rewrite. One. Rewrite. Seriously? You're gonna do it now? Man. Rewrite. Backwards. How to. Okay. Oh, wait a minute. We could go, like, way back. Didn't I? Oh, I already did that, didn't I? Yeah, power 2. Yeah, that's what I did here. Right, repeat, POW 2 expands all this stuff. Hang on, wait a sec. Add square. Ooh, I could go all the way back here. Oh. Add square. That's so much nicer. Alright, so repeat, rewrite. 1 power. Where is... Okay. Yeah. 1 power. Mol 1. That'll be enough for now. See, it's still not doing it in the B and C cases. That's so weird. I don't understand. Like 1 to the power it's doing. 1 squared. In for the B and C cases, it's simplifying that, but it's not doing the multiply by 1 part. I don't understand why it wouldn't do it. Alright. Hold on. Did it again. It works fine if I take out the repeat part. Just, it's only going to do it 1 at a time, but still. Alright, with this, I'm going to step out for a second, grab a snack, and cycle water, and all that stuff. So make sure that you get up and stretch and do some other stuff, because chances are you've been sitting for a while. Get up. Alright, I'll see you in 3 minutes, and thank you so much for sticking around. My name is Obi-Wan Pez, this is N-Simplex Pachinko. See you in just a few. Well, that took about twice as long as I was planning. Hope everybody's having a good time. What is the snack report? This evening we have some yogurt and granola, which probably more calorically dense than I need, but you know what? It's fine. Would have been better off with some kale. Yogurt is really good for you, generally speaking. Yes, feed your microbiome. So, Waffle, if there's anything that you particularly want to talk about in terms of pre-calc, if there's a certain topic or subject that you're not 100% clear on, or you want a different perspective or whatever, I can probably provide. That is also fair. Well, I can say that, again, Trig's kind of my home base, where I spent most of my last 15 years of my career, working out better ways of teaching it. You can tell by how at least fairly close I can get by just eyeballing this stuff. Yeah. So the way that we've always been taught to do the unit circle and whatever has always been to focus on these angles right here. And generally speaking, I get my students to not worry so much about like what angles they need and methods to construct them and all this other stuff. So I was more concerned with, can we just look at this and say, you know, how would we, if we had a radius of 100 meters, right? Where if we're starting from this point, then what is the circumference of the circle? Right, so okay, circumference is equal to 2 pi times the radius of the circle. In this case, that's going to be 2 pi times 100, so 200 pi is going to be the entire circumference of the circle going all the way around. Okay, so what would happen if we split this into smaller bits? So if we only go halfway around, actually, you know what? Let's not. Right. Normally, I'd actually go through it and be like, okay, let's do 100 meters, and then we'll all have discussion about this. And it's like, okay, what if you divide by a factor of 100 everywhere? Right. These are all linear distances that we're talking about. So if you divide by 100, all the linear distances get shrunk by a factor of 100 exactly. But let's jump to the chase here. If we just have this be 1 meter, then the circumference is going to be equal to 2 pi in meters. Alright, if we end up going only halfway around the circle, then, well, that's going to be pi meters. If we only go half of that again, we can get pi over 2. Opposite that, we get 3 pi over 2. Aha! Right, and then eventually it was discussed like, okay, if you just want like a random arc length, so we're gonna go from here to like here, what's that gonna be? I don't know. Let's just say that this is like 41.3 degrees. Right? How do you do 41.3 degrees when you're looking at arc length around the edge of the circle? And so, okay, students are going, well, I'm going to have to do this as like this is going to still be 2 pi yep times this 41 point portion of the circle.